Hi again. This is Algebra 1, Module 1, Lesson number 9. The topic of this lesson is problems that lead to expressions and equations. There are two objectives in this lesson today. Those two objectives include to be able to write expressions representing things in the real world. And then the second objective is to be able to evaluate the expression or solve an equation considering the expression to answer a question about the real world. So let's look at two examples to practice. Example number 1. A cook makes $16 a day more than a waiter makes. Let X be the number of dollars per day a waiter makes and answer the following questions. A. Write an expressions for the dollars per day a cook makes. Okay. So let's start out. We know that X equals number of dollars a waiter makes. Per day. Therefore, and we also know a cook makes $16 per day more than a waiter. So if X is the number of dollars a waiter makes per day, a cook makes $16 more than a waiter per day. So that's X plus 16 represents this expression. So that's the answer. One B, if a waiter makes $35 per day, how much does a cook make? So we know waiter is represented by X and cook is represented by X plus 16. Therefore, if waiter equals $35 per day, cook equals 35 plus 16 or $51 per day. Now let's look at 1C. If waiters get a raise to $40 per day, how much will a cook make? Well, again, we know waiter makes X, cook makes X plus 16. So if a waiter X equals 40, then cook equals 40 plus 16 or 56. So $56 per day is what the cook makes. Let's try 1D. If a cook makes $65 per day, how much does the waiter make? Okay, we know waiter equals X dollars, cook equals X plus 16. Therefore, if cook equals $65 per day, that's equivalent of saying x plus 16 equals 65. You solve for x, which will represents the waiter. So you transform the equation, so minus 16 on both sides. So x equals 65 minus 16. X equals 49. So the waiter makes $49 per day. Let's try example number 2. We have a genes problem. So this is an applied problem for for biology, biological sciences. If parents have a certain combination of genes, then about 1/4 of their children will have attached earlobes. Let X be the number of children born to a group of couples with these genes. X is the number of children born to a group of couples with these genes. Write an expression for the number of children with attached lobes. Okay, so example 2a. The total number equals X. This is the total number of children. The number of children with earlobes is 1/4 the total, which is X. B. If these couples have a total of 532 children, so 532 children, about how many of them will have attached earlobes? Well, let's write an expression. So 1/4 X. So 1/4 times 532 total children. 1/4 of them will have earlobes. So 532 divided by 4. And you do the arithmetic, and that becomes 133. So 133 children. And then finally, example 2C. About how many children would the couples need to have in order for there to be 240 children with attached earlobes? Okay, so this is like what we learned earlier in this module, where we're solving for X. Instead of X being given, we're solving for X. So in this case, we know that 1/4 X, that's the children with earlobes, equals 240. So we need to solve for X. So X over 4 equals 240. Let's transform both sides of the equation. Inverse of 1/4 is 4, and times 4 on the other side. So that cancels out. X equals 240 times 4. X equals 960. So 960 children. That concludes today's lesson. If you have any questions or would like additional tutoring, please contact Subject Whiz Learning. Thank you very much.